Section 1. A rocket's ascent. Calculus in action. Imagine a rocket launching into space. It's an incredible feat of engineering and a testament to our understanding of physics. But did you know that calculus plays a crucial role in getting that rocket off the ground? Calculus helps us understand and predict how the rocket's speed and acceleration change over time. This ability to analyze and predict change is at the heart of calculus. And it's all thanks to a powerful tool called derivatives. Derivatives are the mathematical tools that allow us to describe and quantify how things change. Section 2. Derivatives. Unlocking the secrets of change. Derivatives are a fundamental concept in calculus, a branch of mathematics that deals with rates of change and the accumulation of quantities. They are not just abstract mathematical tools but have practical applications in various fields. Change is all around us. It is an inevitable part of life, influencing everything from the natural world to human society. The bustling city streets, the changing seasons, and even the growth of plants and animals are all examples of change in action. From the rising and setting of the sun to the ebb and flow of the tides, our world is in a constant state of flux. These natural phenomena are governed by the laws of physics, which can be described using derivatives. By understanding these patterns, we can predict future events and make informed decisions. Understanding these changes is essential in countless fields. Scientists use derivatives to model the growth of populations, the spread of diseases, and the behavior of particles at the atomic level. Professionals in various industries rely on these mathematical tools to analyze data and make predictions. In physics, derivatives help us describe the motion of objects and the forces acting upon them. For instance, when a car accelerates or decelerates, its velocity changes over time. By calculating the derivative of the car's position with respect to time, we can determine its velocity and acceleration. In economics, they help us analyze market trends and predict future growth. Economists use derivatives to study how changes in one variable, such as interest rates, affect other variables like investment and consumption. This analysis is crucial for making policy decisions and understanding the dynamics of the economy. And in engineering, they're crucial for designing everything from bridges to airplanes. Engineers use derivatives to calculate stress and strain on materials, optimize design parameters, and ensure the safety and efficiency of their projects. Without derivatives, modern engineering would not be possible. Derivatives are the key to unlocking the secrets of change and harnessing its power. By understanding and applying these mathematical principles, we can navigate the complexities of the world around us, solve problems, and innovate for a better future. Whether in science, economics, or engineering, derivatives provide the insights needed to drive progress and make informed decisions. Section 3. Limits, the foundation of derivatives. Before we dive into the intricacies of derivatives, we need to understand the concept of limits. Limits are a fundamental concept in calculus and are essential for understanding how functions behave. They allow us to analyze the behavior of functions as they approach specific values, which is crucial for defining derivatives. Limits are the foundation upon which derivatives are built, providing a way to analyze functions as they approach specific values. When we talk about limits, we are essentially discussing how a function behaves as it gets closer and closer to a particular point. This concept is not only foundational for derivatives, but also for integrals and continuity in calculus. Imagine you're walking towards a wall. You can get closer and closer to the wall, but you'll never actually touch it. This analogy helps us understand the concept of limits. Just like you can approach the wall infinitely without touching it, a function can get infinitely close to a value without actually reaching it. Limits work in a similar way. They help us understand the behavior of a function as we get arbitrarily close to a particular point, even if we never actually reach that point. This is crucial for defining the derivative, which measures how a function changes as its input changes. Without limits, we wouldn't be able to rigorously define what it means for a function to change at a specific point. Limits provide the mathematical rigor needed to define derivatives accurately. They allow us to make precise statements about the behavior of functions, which is essential for all of calculus. By understanding limits, we can better grasp the concept of derivatives and how they are used to analyze the rate of change in various contexts. This foundational knowledge is crucial for anyone studying calculus, as it underpins much of the subject's theory and applications. So, as we move forward in our exploration of derivatives, keep in mind that limits are the bedrock upon which all these concepts are built. They provide the tools we need to understand and analyze the behavior of functions in a precise and meaningful way. With a solid grasp of limits, you'll be well equipped to tackle the more advanced topics in calculus. Section 4, Derivatives Unveiled, Embracing Instantaneous Change. Now, let's unravel the mystery of derivatives. A derivative at its core is a measure of instantaneous rate of change. It tells us how much a function is changing at a specific moment in time. Think of driving a car. Your speedometer shows your speed at any given moment. That speed is the derivative of your position with respect to time. It tells you how much your position is changing at that instant. Derivatives provide a powerful way to quantify and analyze change as it happens. Section 5, the tangent line connection, visualizing derivatives. Derivatives have a close relationship with tangent lines. Imagine drawing a line that just grazes a curve at a single point. That line is called a tangent line. The slope of the tangent line at that point represents the derivative of the function at that point. The steeper the tangent line, the greater the rate of change. The flatter the tangent line, the smaller the rate of change. This visual representation helps us understand how derivatives relate to the shape and behavior of functions. Section 6, Mastering Derivatives, Unveiling the Rules of Differentiation. In this section we will delve into the essential rules that form the backbone of differentiation in calculus. Understanding these rules is crucial for anyone looking to excel in mathematics, physics, engineering, and many other fields. Calculating derivatives might seem daunting, but thankfully, mathematicians have developed a set of rules to make the process easier. These rules simplify the process, allowing us to find derivatives without having to go back to the definition every time. Imagine trying to solve complex problems without these shortcuts. It would be incredibly time-consuming and prone to errors. These rules, known as differentiation rules, provide shortcuts for finding derivatives of various functions. They are the tools that mathematicians use to break down complex problems into manageable steps. By applying these rules, we can quickly and accurately determine the rate of change of a function, which is the essence of differentiation. One fundamental rule is the power rule. The power rule is one of the first rules you learn in calculus because of its simplicity and wide application. It allows us to find the derivative of any polynomial function quickly. This rule is particularly useful when dealing with functions that involve variables raised to a power. It states that the derivative of x raised to the power of n is equal to n times x raised to the power of n minus 1. For example, if you have a function like x cubed, the power rule tells us that its derivative is 3x squared. This simple yet powerful rule is the foundation for more advanced differentiation techniques. Other rules, such as the sum rule and the product rule, help us differentiate more complex functions. The sum rule allows us to find the derivative of a sum of functions by differentiating each function separately, and then adding the results. The product rule, on the other hand, is used when we need to differentiate the product of two functions. These rules are essential for tackling more complicated problems that involve multiple terms or factors. With practice and these rules in hand, you'll be well on your way to mastering derivatives. The key to becoming proficient in differentiation is consistent practice and a solid understanding of these fundamental rules. As you work through various problems, you'll find that these rules become second nature, allowing you to solve even the most challenging calculus problems with confidence. So, keep practicing, and soon you'll find that differentiation is not as daunting as it once seemed. Section 7, Derivatives in Action, from Physics to Economics. Derivatives are more than just abstract mathematical concepts. They have real-world applications in countless fields, helping us solve practical problems and make informed decisions. In physics, derivatives are essential for understanding motion, forces, and energy. In economics, they're used to analyze market trends, optimize production, and understand consumer behavior. And in engineering, they're crucial for designing safe and efficient structures, machines, and systems. The applications of derivatives are vast and continue to expand as we find new ways to harness their power. Section 8. Embracing the power of derivatives. Derivatives are powerful tools that allow us to unlock the secrets of change and understand the world around us in profound ways. They are the foundation of calculus and have revolutionized fields as diverse as physics, engineering, economics, and computer science. By understanding derivatives, we gain a deeper appreciation for the interconnectedness of our world and the mathematical principles that govern it. we develop critical thinking skills, problem-solving abilities, and a more nuanced understanding of change. Section 9. Keep exploring. The world of calculus awaits. This essay has only scratched the surface of the fascinating world of derivatives in calculus. There's so much more to explore, from higher-order derivatives to partial derivatives and beyond. I encourage you to continue your journey into the world of calculus. Embrace the challenges, celebrate the victories, and never stop asking questions. The more you learn, the more you'll realize how much more there is to discover.